certification. But it is recommended that you try to finish all the certification during the training time itself, or entire workshop duration only, so that in case if you are facing any issues, we'll be able to resolve immediately, right? Post workshop, maybe we also get busy in other activities and we'll not be able to promptly respond to your queries. So try to complete the certification during the training period only. Yes, you can download all these notebooks. You just need to click right on these. Right. So you select all these notebooks if you want at a time, and right click and download. So it will ask for you to whether confirm whether you want to download it or not, right? So you can do it by this way. No, it is not necessary to go through all the chapters. If you're comfortable with this directly, if you want to attempt for the assessment, that is also fine. You don't have to save anything. Only in the last assessment part, you have to execute all the cells from the beginning and update the code wherever it is required. And finally, at this point, if you are getting congratulations message, that means your submission is correct. Then you have to go back and click here on assess task. Okay. Okay, there is a question where I can see the assessment to submit. So if you go to the 7th chapter, you don't have to submit it explicitly. Just complete the task in the 7th Jupyter notebook. Okay, and then if at the end you are getting successful message here by running this run assessment section, that means you are passed in this course, right? But finally, you have to ensure going back to this course tab from where you launch this task, you have to click on assess task here. So once you click on assess task, automatically it will evaluate whether your submission that you maintained here in correct format. If it is correct, then it will generate a certificate once you click on assess task here. If you are getting error when you are launching the course, try to just log in, log out, or try to refresh the page, right? It will work out. Okay. I hope you are able to go through these first two chapters, right? So again, pay attention here. I'm trying to shut down already existing notebooks. So if I shut down, their context from the memory will be erased, right? And I can directly open now the third chapter. Okay. So in third chapter, again, the same problem statement of American Sign Language detection that we solved using ANN will be solving it using a convolutional neural network, right? So the rest of the task remains same, right? What are the image we are going to pre-process conversion into tensors and all, right? So here they are asking you, while we creating the data set, we have to fix something here. We have to reshape the data set, right? So if you're not aware about that uh, thing, you have to what we have to mention the data set in terms of number of channels, the number of pixels in the row wise, number of pixels in column wise. Okay, so width and height you have to specify, and that is going to be mentioned like this. Okay, so channel image width and height we have to specify like this. So that is what we are going to specify here. And we want to remove the labels from the data set and place it into DF here. So we have to specify here labels. Okay, sorry, label, right? So now they have an exercise for us to work on the data loader part. So here we have to specify one of this function shuffle equal to true. And that we typically do in case of only the training set. For the test data set, we want to calculate the accuracy on entire test data set, not the random test points. So for test set, we don't specify the shuffle equal to true. Okay, so that is one thing. Now here they have mentioned how we are going to construct a convolutional neural network. So typically in convolutional neural network, we'll be having this flow. So we will be having input that we will pass in terms of image. Here we don't need any flattening of the image. We will pass image as it is. Okay. If it is a grayscale image, we'll pass it as a 28 by 28 by 1 or 1 by 28 by 28 as it is. We're not going to flattening it because in ANN, input was supposed to in 1D format. So that's the reason we tried to flatten it. But here it is not necessary. Following that, we are going to apply convolutional layer, then max pool, and then again convolutional and dropout. Then again max pool, convolutional, max pool. Then we will make it a dense layer and finally the output layer. Okay. So we have gone through this all, what is convolutional layer, how the convolution operation is will be performed and everything. So we will just try to construct this neural network that is depicted in this image. And we will be having in output, there will be 24 classes because we have American Sign Language classification where 24 type of images are there. Kernel size we are going to specify here, that is 3. And finally, the flattening layer will be applying at the end here, where we are going to add some fully connected neural layers. Okay. So we'll create a 2D convolution. So we will apply the kernel size, stride and padding equal to 1. And the number of kernels will be applying 25. Then we will be applying normalization, nonlinearity using ReLU and max pool operation to reduce the size of feature map. So this is my first convolution layer. Following that, I'll be having second convolution layer here and similar pattern, the convolution with the now 50 layers, 50 masks, then batch normalization, then ReLU, dropout, and max pool. Same is repeated again in the third convolution layer. And finally, we are going to flatten it to ensure the number of, finally, we are going to create the fully connected layer just like N and we did. So that is what added here, linear layer. Just like in previous chapter, we added linear layer. Then dropout layer. And finally, again, 512 neurons in the last layer and number of classes in the last layer actually. And there will be 24 here. Okay. So this is the entire neural network architecture and details about all these max pool and everything already we have discussed in the day 2. So I'll skip that part. And now we will compile. The loss function will be the same. Then optimizer is same. Function batch accuracy is also same here. The training layer is going to be the same. So only thing is they are asking is to fix few values here, but they have already provided the solution. So let me first of all only use that. The same function is requested here also, right? So there is nothing new. So I'll just use that only. And we have to start training this model. Okay. So slightly it will take more time for training this model. We have 220 epochs and it is going to be convolutional neural network. So slightly computationally intensive compared to ANN also. Okay. So let's wait for this training now. And I want you to now quickly go through this CNN chapter and try to uh, understand the neural network and execute this, and we'll wait for its final accuracy. Okay. Right. So take 5 minutes and go through this. It is very simple chapter. Okay, so you can observe here, we are getting using this CNN almost 99 or 100% accuracy on training set. but slightly lesser in case of validation set, okay, or the testing accuracy. Fine. So this means just by using CNN, we are able to avoid the problem of overfit that could occur in the second chapter, right, where ANN used for American Sign Language detection. Okay, so here your accuracy is more improved, but good news is we also have one more way to improve the accuracy further, or we can generalize it, because you can see accuracy is slightly, dropping and increasing, dropping and increasing. So we can make it stable by using some thing called as a data augmentation. Okay. So let's move to the fourth chapter where data augmentation is discussed. Again, I will shut down first all these chapters and then I will open the fourth chapter. Fine. Okay. So now same problem statement is there again, American Sign Language, and we will try to solve that using data augmentation. Not actually solve, we'll try to improve the performance by means of data augmentation so that your test accuracy will be stable. So we have seen the test accuracy was fluctuating, and we will try to ensure that test accuracy remains consistent and consistently dropping, and it will be kind of smoother compared, not very abrupt changes. Okay. Now, what do you mean by data augmentation? Here, basically, we are trying to you work on the same model that we have created using the previous chapter, right? So data preparation and convolution model will be the same here, right? Model is same. Only thing is we are going to work on the data augmentation now, right? So before this data augmentation, all the cells are borrowed from the previous chapter. So here we are going to first of all understand what do you mean by data augmentation. So all the images we have in this particular data set are captured and they are following a uniform pattern, right? So all the images that we have, right, they're having all the hand gestures typically at the center, right? And they have been captured from same source or distance, from the same distance from that capturing device. So obviously the size of the hand remains almost same in all the images. All the images where the gesture will be perfectly vertical. So this is the first gesture, right? So one pointing is vertically upward, right? Other thing is all the images are captured from a person with a right hand, right? But it's not necessary. It is possible that gestures can be made by the person who is lefty. So in that case, your gestures will be different, right? So likewise, it is also possible that here all the images are captured with the same illumination source, right? So same lighting condition. But what happens when you put into the production, it is not guaranteed that the person will be making those gestures from the same space or from the same distance between your camera and that person. It may be increased. So if the distance increases, the size of the hand is going to reduce. If distance is decreased, size of hand is going to increase, and it is possible that where sometimes part of your hand is going outside the image also, right? Maybe you have this sort of gesture, right, where the part of your finger is going outside the image. It is possible, right? When you go for the production, when you put into the camera, so it is going to capture live action. So it is possible that gestures are going to be, a hand is going to be outside. Maybe lower part of hand is going outside, or maybe this part is going outside. It is also possible that the person is not going to make exactly vertical gestures. Maybe it is possible that the gestures is slightly inclined. So it is fairly inclined, but assume it is slightly inclined. So in that case also, the problem will occur because your model is not aware of this sort of inclined gestures. Maybe 15-20 degree inclination is not recognized. So if some part is going outside this image, then again your model will be failed to recognize it, right? So that means we have to generalize the data set just like what will happen in the real case, right? So right now we have perfect illumination source. Maybe when you put camera in the production and this model, so maybe the lightning of this particular room will be different, right? Maybe it is a little bit darker in this room. So in that case, images maybe a little bit darker and your model will fail to recognize the uh, gestures, right? So that means in given data set, we don't have a generic data values or the variance will not be there. So in order to introduce those sort of generalized data, we are going to perform augmentation, right? So this data augmentation is we are going to deliberately make all these transformations on the image and we will try to create or increase the data set by following these augmentation techniques. Okay, so this is augmentation techniques we apply. So we will pass one image. Okay, let's say it is an image with this, let's say, hand gesture. Okay, now we will create one more image. Maybe it is going to be slightly zoomed in version. Okay, so slightly zoomed in version will be there, right? So now size of image is more. What I'll do, another image I'll create using that some. So here I will apply scaling transformation. So I'll increase the or zoom in. Here I will do the rotating transformation. I'll rotate this image, right? Maybe now image will look like this. So my gestures is going to be like this, right? Then I will create the same image with the change in contrast value. So maybe the same image will be there, but let's say I'll defer the constant contrast value. Okay, so maybe some contrast related transformations will be applied here. Okay, so contrast. So the thing is that I'm trying to generalize this data, right? After that, maybe I will reshape transformation. Okay, so in that case, maybe some uh, part of this gesture is going outside the image. Okay, likewise. So from one image, I will try to create all these different types of image and I'll feed those images to the neural network, right? So while training itself, I'll feed so that in general, model will get idea that it is also possible that you'll get different size of hand gestures, right? One more thing is flipping, I'm saying. Okay, flipping means horizontal flip. If person is, let's say, lefty, right? So let's say this is a person righty. So if lefty person makes those gestures, so it will look like this. Okay, so this is your thumb. Okay, sorry about my no uh, drawings. It is terribly wrong here. But at least you'll get idea that now assume this is the thumb pointing in this direction. Now the thumb is pointing in the opposite direction. So it is a flipped version of this. Okay, or mirror image of this. So if these are the right hand person gesture, so this becomes a left hand person gesture. So now it will also get the knowledge about all these different variations in our data set. So now we have model that is learning very generic about things about our data set. Okay, and that is what we are going to do manually first before we feed the data to the model, right? So that is the objective for this particular node. So you can see the randomized crop transformation we are applying, and initially my image is like this, right? So randomize, sorry, now you can see randomized crop. So image, some part of the gesture is going outside the image, right? So we'll take approximately 70% of the zoom in version and then we are going to crop it. And again, we are going to rescale to match the ratio of the original image. Okay. Then randomize horizontal flip. You can see here. So this is the gesture we have. And if I do the randomized flip of that, so it will get, look like as a right hand person gesture gets converted to left hand person. Okay. Now, question is, can you think about why we are not making vertical transformations, vertical flips here? Can you guess? Why vertical flipping we are not performing here?
So that will be quite unnatural.
Yes,
Naturally, that
exactly. Right. So gestures will be always made like this. So we will not have gestures where your hand is like this. Okay, making point in this direction. Okay, so that is not going to be a valid or natural gesture, right? So it makes sense to make a, horizontal mirror image, but vertically, if I try to do, the gestures will be pointing downwards, and that is not going to be a natural way. Okay, so that's why we are not going to make this vertical flipping. Then randomized rotation will be there, and we are going to rotate our images by 10 degrees. And you can see here slightly rotated. And because the image is rotated, so you can see the corners are getting black values, because after rotation, we don't have anything to put over there. Okay. Then likewise, we'll be having some color jitter transformations will apply. So we will variations of brightness 20%, contrast 50%, and those transformation will apply. And it will also apply some variability in your data set, okay, in terms of brightness and the contrast. Likewise, now we will compose all these things together and we'll place into one transform functions, and all these transformations will be applied on the data set that we have in our training set. And before we feed it to the neural network, we will be applying these transformations. So now your train function remains same, but while we pass your input data set here, the features or the images, we are passing it to first transformations, and then we are passing it to the model for performing predictions. Okay, so in earlier case, we were just passing X here, but now we are passing the after transformation. Okay, and the same with the validation also, we will perform predictions, and let's see now whether our accuracy is going to be stable or not, and how much accuracy we are getting. Okay, so let's wait for 5 minutes. Meanwhile, you go from the first section from this chapter and try to get familiar with that, execute it, and let's see how much accuracy we get here. Okay, I'll wait for 5 minutes for your experimentation. Meanwhile, if you are having any questions, you can ask. I'm not speaking. I have just gave 5 minutes time for experimentation. If that is the error in chapter number 3, data set is not defined, that indicates you are not executed the previous cells properly. Right. So again, go on from first cell, try to execute in order, and then this error will be resolved. Okay. So now, so far we discussed only the things that we have seen so far, like how to use ANN for classification, CNN for classification, and data augmentation. Okay. Now, chapter number 4A is just to say how to save the model and how to, perform the uh, load the model and again perform the predictions, right? So I'll skip that chapter. It is just how to save and use that model. The most important chapter here is you have to use pre-trained models. Okay. So the thing is, let's say you have one problem statement and one data set is there, right? So you have uh, hundreds and millions of images are there. Let's say 1 million images are there. And on this, these are generic images. Like, so for example, images consist of nature, images consist of animals, right? Images consist of vehicles. Likewise, all the generic images are there, right? And on these set of images, we trained a model, right? M, right? And which is having, let's say, around 1000 categories. Okay. Now you can see this model is going to be very complex, a very deep neural network will be having because huge data set is there and around 1000 categories are there. And these are very generic images. So the complexity of the model will be high and it will take more computational resources, more time and more data set to train such model, right? Now question is, what if I have another problem statement, right? So this is one problem statement. You created one model. Now we have another, let's say, problem statement, right? And let's say where I have to perform the generalized classification of, let's say, what I can say, the aeroplanes, right? So in that case, now we have special categories of aeroplanes, right? So maybe some of them are domestic aeroplanes are there, right? So some of them are going to be private jets are there, and some of them are going to be, let's say, international flights are there. So in this particular problem statement, we have category of only airplane, right? No specific related to domestic or likewise. But here I'm having only 1000 data points, right? So I'm having less data here, right? But I want to use learning from this model, right? So question is, can I take the learning of this model, right? Learning of this model, and can I use the same model to perform the classification of these, okay, domestic airplane or maybe private jet or international, right? So because this model has seen how general vehicles look like, how aeroplane looks like. So that sort of knowledge is already there in this particular model. That model has seen the pattern of this airplane. Now, can I borrow this learning or can I borrow this entire model as it is? And will I be able to perform the classification of these aeroplane categories, right? So the thing is, model knows already how aeroplane looks like. So this time, now model don't have to learn explicitly how airplane looks like. Right. So if I take a domestic aeroplane or private jet or international flight, so it somehow they look similar. Maybe 70-80% similarity will be there. Now only 20% extra knowledge I have to gain to explicitly categorize it as domestic, private, or international. Right. So here I'm transferring the learning of this first model, right, to solve the another problem. Okay, that is called as transfer learning. Now, when it is possible to perform the transfer learning, I cannot use this model for, let's say, in the healthcare domain, right? I will not be able to use this in healthcare domain. I cannot use the same model M for your X-ray on X-ray images, right? The reason is this model has never seen the X-ray images and the context is totally different. Domain itself is totally different. So in that case, I will not be able to transfer the learning of M to perform this X-ray images classification. So there has to be some sort of similarity here. Okay, so what kind of generalized things that model has learned, right? And what specific things this model is going to perform. Okay, that matters a lot in this transfer learning. Okay, so now let's try to understand what we have this transfer learning in this chapter. So we will be having one model VGG16, right? So this model will be having. So this is a VGG16 model, very old model, which is used for on the data set. There was an ImageNet challenge where we'll be having millions of images, generic images, and which is trained on 1,000 different categories, right? Which is also having the categories of animals, dogs, cats, etc. Right? Now, can I use this model to perform prediction on only cat and dogs? Because this model has trained on 1,000 different categories, right? So output layer in this model is having 1,000 neurons. I think somebody's mic is open. Just check. Aryan. Okay. So you can see here in the this is my entire model, and this is here only the last layer is depicted here. So 10,000 classes are there. Now my question is, this is the entire model. Can I use it for only performing two classifications, whether it is a cat or dog, or whether cat there is a cat or not? Okay, because now this model is going to tell you one of the 1,000 categories, or sorry, not 10,000, is 1,000. Okay, it is 1,000. Right, so 1,000 categories are there, out of which now we are not worried about all these 1,000. We want this model to tell whether there is a cat in the image or not. Okay, or cat or dog. Only that sort of output I want. Right. So question is how we can do this, and this can be done using the concept of, as I mentioned, that is transfer learning. Okay. So what we'll do first of all, we will take we'll take this VG16 model as it is. We will load here, and we'll transfer this model to GPU. Right. So this VG16 model, it is already available in the Torch Vision. Right. So in PyTorch, pre-trained models are there. So VG16 model is there, and their corresponding already trained weights are there on this ImageNet dataset. Right. So this model, if you try to see, it is very deep neural network. So which is having 16 layers. Right. So 16 layers will be having, and in final layer we are having 1,000 neurons. Okay, and input is of size, I think 224 by 224, right? And output layer is having 1,000 neurons. Now here we are having all these input size is 224 by 224, right? Then this is the image size. Okay, output dimensions are 1,000, right? And if I load now any image that we have in our data set, like this we have, right? So in the data flow folder, doggy door image folder is there, and happy dog image that we have loaded here. Okay, now this image is very high definition, so which is having more than 224 pixels, right? So 1080 by I think 1080 number of pixels are there. Okay, so but our model is expecting input as 224 by 224, right? And it is expecting color image, so no worry about it. So here we are going to pre-process the image, and we have to ensure that image after pre-processing, here this is my original image, and after pre-processing it is going to be 224 by 224 by 3. Okay, and this is the batch size, that means how many images we are going to pass at a time. So in this format, we have to first of all convert, and load and pre-process function is defined for that only, right? Now, what we'll do, we will
Sir,
let's check it
sorry,
out.
in the previous output, there are four dimensions for the image, correct?
Yes,
Processed
not
image.
four dimensions. This dimension is for the batch. How many images at a time I'm going to pass?
Okay.
Okay, this is a channel. This is height and width, and this is uh, your number of images that I'm going to pass.
That says, yeah,
Okay,
thanks.
so right. So now, if you see, our image is going to be look like this, and when we want to perform this predictions, so first of all, here we'll be having execute first. Okay, so here for every category, right? So we have cat, beer, and all. So for every category, we will be getting some sort of probability value. Okay, so how much you are confident about this belong to this particular uh, uh, brown category, brown beer category, black beer category, and so on. So you can see here, when I'm performing the prediction, so it is showing me top results that it can be maximum probabilities for brown beer, then second maximum probability is for American black beer, and then sloth beer, right? So for dog also, it is giving me top three breeds, right? It looks like maybe bull terrier, or maybe the American terrier or pug. Okay. Likewise, we will be having this deer and all the cat also, tiger cat, tabby, and Egyptian cat, and so on. Right. Now our task is to only tell us that whether dog belongs to that whether there is a dog in the image or not. Right. And we have seen in that particular ImageNet challenge. So if you go and investigate the number of categories there, so the category indexing from 151 to 268 belongs to dog, right? So obviously for dogs also we have different breeds, and from 151 to 268 we'll be having different breeds of dog. And same way, 281 to 285 will be having these numbers indicating our output prediction indicating it can be a cat, right? So which cat it is doesn't matter for us now, because we want to tell whether it is a dog or not. So if it belongs to 151 to 268, it can be belonging to dog category, and 281 to 285 it belongs to cat category. Okay. Now here a simple dog-eat-door function is defined, so which is expecting input image, and we will pass image for the pre-processing first of all. Then the model is going to perform prediction, and it is going to give you what is the index of that. Okay, and they're asking you to fix me this part. So here just you have to mention the dimension equal to 1. So that means in the dimension 1, that is in column where you are getting maximum probability for this image. And that index will be given by this argmax, and that will be the ID. And if that ID belonging to in this range, we are calling that, okay, dog is there. So dog, come on in. If it is belonging to that 281 to 285, so we are going to display message, it is stay outside. And here it is not a dog, just stay outside otherwise. Okay, so if you just run this, so now you can see for the first image, that is brown beard is saying you are not a dog, just stay outside. Then second is here it is showing your 179 is the index, so it is a dog, come on in. For that message it is displaying. And for cat it is saying kitty, stay inside. Okay, so it is simple. Here we are not done yet any transfer learning, but using that function, we just try to mention that after prediction whether it belongs to cat category or dog category or otherwise, right? But that is not kind of transfer learning. We are just trying to squeeze the output number of neurons. Even indeed, we are not even squeezing. We are just squeezing the what output we are going to expect, right? So again, the model is same. It is giving you the index value, but these if statements are specifying whether it is dog or cat or bear, right? Now, this is your entire uh, model which is trained on 1 million images. And here we have actually going to perform this transfer learning in the chapter number 5b. Okay, so here what we are going to do in chapter number 5b, we are not going to take the model as it is. We are going to perform some sort of training on that model also, right? So we have seen in case of ImageNet that it is going to only give you all type of dog categories, right? And it is going to keep other out animals outside. Now in this exercise, they are asking us to create a function or kind of model which lets in only a particular type of dog, right? And in this case, they have considered a new type of dog that is named as Bo, right? And it was the United States first dog from 2009 to 2017, right? But we have less number of pictures for this bow, and they are placed into this presidential doggy category. Okay, if you go into that dog category here in training set, we'll be having bow images. Okay, around maybe 16 or 20 images we have, right? But obviously, within using this 20 images of this dog, we will not be able to train the entire neural network from scratch, right? Otherwise, it will get overfit. Now, what we'll do, we will use pre-trained model, right? So we will use again VGG16 model, same model. We will transfer it to the device here again, right? Now, in addition to that existing VGG16 model, we are going to add few more extra layers, right? So let me visualize it first. So we had already all these layers of the VGG16 model, right? I'm not going to draw those all neurons, but we already knew that in the last layer of this VGG16, there were 1000 neurons were there in the last layer. Now, what we'll do, this is going to perform 1000 class categories, right? So what we'll do, we will add a new layer here. At the end, I will add new layer, okay, which is going to have only, sorry, it is a simple classification. So we'll be adding only one neuron. Just a second. Okay, so we will be adding only one neuron here at the end, right? So number of classes are only one here. So I will be adding here only one neuron. Okay, and I will add these new fresh weights here. Okay, note that this model, till this model, okay, I'll just highlight this model, which is already trained on that ImageNet data set, this part of your model. Okay, and we will not modify the weights of this model, we will freeze them. Okay, so freezing means in neural network training, these weights will not get modified. Okay, and we will be adding a new neuron here, and corresponding weights are also added here, and these will be trainable. Okay, so these will be trainable. Okay, so now what will happen, this will going to tell you whether there is a dog bow or not, right? Only one neuron is sufficient to tell this. Now, why we are freezing this model? Because this model has learned all the type of dogs. So even Bo, if you consider it is also a dog, so obviously it is having some common features like all the already uh, uh, the dog images that we have passed to this model. So that memory is there, right? So you don't have to learn the Bo categories from scratch, because these Bo categories or the dog in general dog categories are already learned by this model, right? Now these layers, these weights, the last layer are going to learn only specific things about the bow, right? We don't have to learn from scratch. Now what we'll do, we will take this model, we will take those 20 bow images, feed it to the model, then we will calculate the loss function, back propagate, and in back propagation only these weights will be updated. right? And rest of the weights will not be modified for this. And what's the advantage? This VGG16 has transferred all the learnings on those 10, sorry, 1 million images, right? Out of which maybe we have around 10,000 images related to dog categories. So generic features are already learned by this VGG16 earlier. So we are taking this learning and we are adding an extra layer just to add some specific features of this board dog, and those will be learned in these particular weights, right? And that is what we call it as a transfer learning. And you can see here in this model, I'm going to perform the same thing, right? So this is more model, right? And then we will compile the model, freeze, transfer it to the device, and perform the simple, again, the same kind of model training will happen, right? And in addition to that, we'll also add the data augmentation just to increase the data set and generic things about the board dog. Then batch accuracy, model training, everything remains same as it is from the first chapter itself. And you can see here now with this also your model is almost getting 95% accurate about it, right? So this is what we are getting. And for fine tuning means we'll just play around with the learning rate in the gradient descent we have seen, right? So we will just make it a small size of the learning rate. And by means of that, you can see here accuracy is finally 93.33. Okay. Now we will pass any bow image to this model and let's see whether it is going to tell the bow in the image or not. Okay. So there is a cat in this image and there is a bow in this uh, previous image here, right? And we'll just call this function, sorry, call this function. If prediction is less than 0, it belongs to bow. If it is greater than 0, it belongs to not a bow. Okay. So it is another type of dog, right? But it is a model is saying that you are not a bow, stay out. And this is a bow. It is saying that yes, let him in. Okay. So this is just to summarize, this is what we are doing in this entire Jupyter notebook, right? So we are using that existing model, place it here, which is Gnet.
Sir,
So this is,
validation accuracy is coming higher than the train.
yeah, because what where we are having here, yeah, because it is not a stable right now, right? Because we have only 10 data points, sorry, 20 data points, but in general, at least you are seeing here, accuracy is reaching towards 90% in both cases, training and testing accuracy, right? Because we have less data set, so obviously it is going to bit fluctuate, but at least once you fine tune here, it is becoming slightly closer here, okay, with the learning rate, if you make it close to 10 to the power minus 6, I guess. Okay,
Sure. Thanks.
fine. So this is about the last chapter. Unfortunately, I don't have much time today. That's why I tried to rush and give you flavor of all these chapters. But this is just to give you, a brief about all these chapters, so that when you try it by yourself, you'll be having at least some context that what we are learning in these chapters and what is the objectives and what are the outcomes you can expect, right? And now there is a final assessment for you where you have to work on this assessment and you have to complete it. I'll just walk you through, and I'm sure all of you will be able to do it. And if you invest now onwards 10 to 15 minutes of time. So first of all, we are going to import, and here now the problems is a fruit classification. Okay, so we'll be having 6 categories here in this classification. So fresh apple, fresh banana, fresh orange, rotten apple, rotten banana, and rotten orange. So we'll be having 6 categories in total. Okay. And what they're asking you, you want to only one more. Okay. So what they are asking you, so first of all, you will use the base model that is ImageNet again, which is a 16 model that we have used, right? So using the same model, we are going to modify the final layers. We are going to add new layers to this model. Okay, that is what they have added. So number of classes are going to be the 6. So you have to mention it here 6. Then here you have to use default keyword, that default weights we are going to use. Here we are going to use false here, right? So likewise, those changes you have to make just like we did in the previous chapters. They are already mentioned the um, references in which notebook you can find it out, right? So likewise, you will be having this VG16 model with the last layer is having only 6 neurons. Okay, loss function will be cross entropy loss, right? So we have seen that cross entropy loss many times, right? You just need to copy paste it as it is. Yeah, maybe he used this cross entropy loss. I think in chapter number 2 also we used. I'm just referring it for the not spelling mistake should not be happening. It is going to be case sensitive. Okay. So this cost entropy loss we use. So you just need to copy paste it here. Okay. And likewise, you have to, progress. So torch.nn is not mentioned. Okay. So likewise, you have to go. Now they're asking you to apply for all these transformations, and transformations we applied in this chapter number 4. Okay, so all these transformations we applied. So what you have to do, you have to combine all these transformations together. Okay, and you have to apply it here. Okay, so likewise, you can change these values, right? So we'll apply these transformations also. Then loading the data set. I don't think we have to fix it anything here. Okay, then batch size you have to specify. We'll specify 32. Then shuffle equal to true that we have seen in the previous chapter, and shuffle equal to false for the test data set. Right. And then that's it. We will train this model for a few epochs. And let's see what's the accuracy we will get. Okay, random trans not defined. Hopefully, I have executed all these cells previously. Shuffle equal to true, shuffle equal to false. Random transforms. I think we have to mention random trans here. Is it? Hopefully that's there. But at least you got the idea what changes you have to make it here. Okay. And yes, so you can see model started training, and it is giving accuracy around 89%. And in order to qualify for this certification, they're asking you to go for the 92% accuracy at least. Okay. So with these minimal changes, now you can see you are getting 93% accuracy. Okay, how many epochs we tried? 10. Okay. It is already giving me 93% accuracy, so I'll directly go for the evaluation of the model. So this is required. Why it is not working? So it is required only if, right? So I'm getting a 93% accuracy. And if I run this assessment, it will show that congratulations, you passed in the assessment, right? And I can go back and click on assess task now. And if I do that, it will show me a message that congratulations, you passed, and it will show here passed flag somewhere here below. Let's see what message we get here. Right. So it is showing congratulations, you passed the assessment, and you can go and check your certification. Right. So here it is showing me passed flag. And now you can go in my learning section and you will see there will be a certificate appearing here. Okay. So this is how you have to proceed. I had to, rush towards the end because, I wanted to finish the certification, demonstrate the certification process during this session only, so that there will be minimal issues for the participants later on. Okay, so this is how you have to proceed and you have to complete the certification. And once you complete the certification, you can download it also, right? Fine. So I hope at least few of you are able to generate the certificates. How many of you generated? Mostly, I think those who are attending parallelly will be able to generate. Yeah, great. Okay. So if you stuck at any point for this certification, right, you can also drop message in the WhatsApp group. Okay, we'll try to resolve your doubts. Okay, and try to complete the certification by today itself. And now you can see here the timeline. Here I am left with I have used only 1 point or almost 2 hours. Right. Now I'm done with this. I can stop this task, and later on, when I restart, I'm going to get again a fresh cloud instance, right? So whenever you're working on this, make sure to complete in one setting only, because if the cloud instance is getting restarted, then again you will get the fresh instance. Again, you have to start from the scratch for the 7th chapter. Fine. So we'll conclude here. I'm sorry I'm stretching a bit more, but if you have any questions, you can ask. Otherwise, we have concluded this session. And for tomorrow's session, also you will get access to new course, that is applications of AI for anomaly detection. And for that course, already the prerequisite is you need to understand XGBoost. That was not in the scope of this particular course, but GAN and autoencoders are the prerequisite. So if you have any doubt in GAN and autoencoder part, you just go through my session recordings are available on YouTube channel, and the recording link is also provided with you. If you want, you can revise it, but if you know autoencoder and how GAN works, we will be able to complete the second certification tomorrow. And the third is tomorrow also we are going to introduce diffusion models, right? So that was not covered in the earlier planned schedule because GAN took a bit more time. So we planned this diffusion session separately because it takes around 1.5 hours to demonstrate and explain the mathematics behind the diffusion models. Okay, fine. So if there are no doubts, then we will conclude here. Okay, thank you all.
Thank you, sir.
Yes. There is a feedback link. Just submit it before you leave.
Thank you, sir. Sir, this recording will be uploaded by today or today's recording?
Most likely, I think for rendering, it will take some couple of hours, right? So maybe today itself will upload, or max to max tomorrow morning, we will be able to upload these recordings, right?
Okay,
All
sure.
the previous recordings are already available on the YouTube.
Yeah, yeah. Thanks, sir.
Sir, after getting the certificate, what should we do? Should we send
Your
it to
voice
you?
is bit low. Your voice is low. Can you repeat? As of now, you don't have to do anything. Just keep it with yourself. We will share a separate drive link where you have to upload it. Okay. So just hold on for a while.
Hello.
Yes.
Good evening, sir.
Good evening.
Sir, that means the loading is high. So I think you suggested to go with an mobile Wi-Fi, right?
Loading, it is showing loading that option that a bar is moving, or it is not loading the page itself.
No, it does not load the page itself.
Yeah, in
Means
that
it-
case, try to change the network, high speed network, or log out and log in again and try, because as such there should not be any issue. Some local system issue will be there.
Okay.
So you
And I
just
think
need to
I
go
think
with the
the amount of time that is 9 hours is completion time, right, sir?
no. You use it for, let's say, today we use for 2 hours. So from
Ah.
that 24 hours, 2 hours will be deducted, and 24 hours are left. You can
Okay.
use it even after 1 week also. That remaining
Okay.
24. Okay.
Okay. Thank you,
Yeah.
sir. Thank you.